Hi, this video we're gonna continue look at moment of inertia and really kind of get comfortable with integration. And here is the shape. It's parabola y equal to kx squared. And they want us to find out the moment of inertia regarding x rotation and also the y-axis rotation. And let's go use our general steps. In order to find Ix, we're going to first draw a rectangle. Draw a rectangle that is parallel to x-axis. So then we're going to use formula of y squared dA. So in order to do that, let's figure out this rectangular strip area first. What's going to be our length here? Right? We know if this point is going to be on this curve, y equal to kx squared, so this point is going to have a coordinate of x and a y here. So our x is going from here to here. That's our x. So in order to find out rectangle length, that will give us this entireness, which is b, right? So it will be b minus x. That's our question mark. And our height, of course, is going to be this differential depth, that length, height, so that's going to be our dy. So that's our dA. Then continue to do that. So my equation will, this is my dA. In my equation, I'll have y squared times dA. Okay, so we got this equation, and obviously we'll integrate with respect to y, and you have an x here. So in order to do that, we're going to have to solve our x. So how do we do that? First of all, there's a coefficient in this equation. That's actually what I should do first. I'm going to solve that coefficient. Because, this point, 0, 0 going to satisfy this equation. Satisfy this equation means you put the x equal to 0, y equal to 0. However, you cannot solve k. So we're going to use this point. This point have a coordinate of b and h, right? bh. So then plug h for y and plug b for x. Then we can certainly solve our k. So we'll solve k. K will be equal to h over b squared. So knowing that, we're going to put that equation. So our equation will become y equal to h over b squared x. Then what we're trying to solve is we're trying to solve x. Our x will be equal to b squared y over h, right? So that's going to be our x. Oh, sorry, this is square, my bad. So x squared equal to that. Then we're going to take a square root. So what's our x going to be equal to? Our x is going to be equal to b and then go ahead, let's redo that one. So our x is going to be equal to it's going to take out b, so it will be square root of y over h. Okay, so that's what we have so far. You could potentially taking out b over square root of h because those are constant, so we'll just have square root of y. Okay, so that's what we have for x. Then we can plug into this equation here. We'll have y squared, then b minus x. X will be b over square root of h. And we have square root of y, then dy. Okay, so far so good. We are integrated regarding y, and our y ranges from 0 to h for this problem. Now, let's go ahead and look at the first term. So that would be b, taking out of integral, y squared That would be y cubed over 3 after integration, right? Then now let's look at the second term. You have b over square root of h. Again, that's a constant taking out. And inside, what do we have? We have y squared. Then we also have y square root. So it's y power of 1 over 2, then dy. Continue right on. So we have y cubed and b square root of h. Then this y, basically it's together, it's y 3/2. And then we are going to add exponent over 1 to get a new exponent. So it will be 5/2. Then we're going to divide by this new exponent, divide by 5/2. So basically it's going to times 2/5. Okay? And all of those is going to be a range. We said the y range is from 0 to h. Let's see how we do. So b over 3 and y will be substituted by h, and then the second term, not 5. Second term, we have 2/5, and in that situation, it's h, and we have 5 over 2nd. Okay, let's see if we can simplify our second term. So it's 2/5, right? And then b. Then here it's h power of 2, and here is 5 over 2. Then you are going to basically divide. Then exponent is going to be subtract. So it's h 5/2 minus half. That would be power of 2. So here I realize there's something wrong because I have bh squared here and here bh cubed. There's something wrong. So I have to go back to see where the troubleshoot, see where's the trouble. And I realize right here I have 2 and 1/2. When added together, this is not y 3/2, it's 5/2, right? 2 plus half, it's 5/2. So in that situation, let's see what do we need to change. Then we're going to plus 1 here for after integrate, so that's going to be 7/2. Then divided by 7/2, that would be times 2/7. So in that situation will be 2/7 and here. Then let's see what we have here. So it will be 2/7 b, and here it's still h over power of half. And then that will be 7, because 7/2 minus 2/2, that we're going to give us 6/2 would be third. Now we're more like it, right? So we'll have the same like terms, which is bh cubed. Then we'll have 1/3 minus 2/7 right here. And then let's see what we have there. Then we'll have common denominator 21. Then have 7 minus 6. So it'll be just 1. Then we'll have bh cubed. Okay, so that's our ix for this one. Okay, now we can go ahead and solve our iy now. How do we go ahead and find iy? I think iy would be easier, right? Let's go ahead and see. If I'm going to draw the same parabola and x and a y-axis, and since I already solved this k, which we had right here, it's h over b squared x, and base is b, height is h, and now we're trying to solve our iy. Remember the equation for iy is going to be x squared dA. In order to solve iy, we are going to draw the rectangle that's going to be parallel to y, which is vertical. So now our goal is to figure out the dA, this rectangle area. We know this is going to be dx, and we needed to figure out the height. because any arbitrary point that's going to be x and y for coordinate. So this will be just y. So dA will be y dx. Okay, I think solving IY might be easy here. So we plug it in here. We'll have x squared times y dx. We'll integrate about x, so we're just going to substitute y as x. We already have a y equation. Our y equation is going to be equal to this equation right here. It's going to be h over b squared x squared dx. So taking out our coefficient out, h over b squared, then inside the integral we'll have x to the fourth dx. Then integrate that, we'll have x fifth over 5. And our x is going to from where? From 0 to b. Then go ahead, plug that in. We'll have that. Then this will be relative straightforward. The answer for this will be fifth hb cube. All right, so that's what we have for ix and iy.